So, we started with the first story. This is maybe different for many of you, but those who are in physics, those who are in computer science, those who are in imaging, I think will appreciate this. So, this is about metallurgy or metal casting, essentially a process by which you melt metal and pour it into a mold and then create useful objects. Okay? This story is about that. What used to happen is that I was doing PhD on this topic, and my prof said, no, you have to go to real life and see the stuff. So, I used to visit these foundries, and it is incredible. These foundries, when the metal is poured into mold, it is actually a very you can say dramatic event. Okay? And I used to love doing photography. So, and it is a photographic challenge because it is like white hot metal, and the foundry is usually very dark. So, its contrast is very contrast ratio is very high. So, it is very difficult to photograph that. So, it used to challenge. So, but you can see these pictures. So, I used to do that. Of course, I ended up asking a lot of questions, lot of stupid questions. Why are you doing like this? Why are you doing like that? What is this? What is that? And slowly start understanding this you can say the art and science and technology of metal casting. Okay. And slowly realize that it is actually very big industry. I mean, if you see in this picture, those big red circles are the places where you have more than 100 foundries, a cluster of foundries. So, Howrah and near Delhi and near Ahmedabad, and then you have Kolhapur and Coimbatore and so on, places like that. So, it is a very major industry, I mean contributing a lot to the in terms of employment and exports and things like that. I realize that if you do not have foundry industry, most of our life as we know will go back maybe a few centuries back. I mean, you name any sector, our transport sector, defense sector, machineries, household goods, even art and crafts and medical devices, they all rely on metal castings. So, without this, in fact, they say this is a mother industry because it feeds all other industries. Okay. So, when I started looking at that, I started realizing that, hey, these guys have a lot of problems. They talk about, in most of the industries, they talk about ppm, which is parts per million rejections. Whereas in foundries, if you look at 5% means it's like 50,000 parts per million rejection. That's a lot of defects. And if you go deep into that, it's all about physics. Okay, you have flow, you have stress, you have gas evolution, you have heat transfer, but all these phenomena are happening at the same time. So, you can analyze one at a time. You can analyze only heat transfer or flow or stress, but even all these things come at the same time, it is not very easy to understand what is happening inside the mold cavity. Okay. And we call it as rocket science for rocket scientists. Okay. So, one of the reasons, one of the major defects is that you get these small holes in castings, and this is dangerous. If the part is rotating at a high speed, at high velocity, with the high stresses, a hole can break up into a crack and the whole thing can be dangerous. Now, why does it happen? Because there is what is called as a hot spot. Okay? That is the point which solidifies last. The point solidifies last is where you get a shrinkage cavity hole. Okay? You can avoid that. You can avoid that by simulating that on a computer, but that is multi-physics. You have to simulate that. Then you can figure out why defect happened. That is called hindsight. But also you can change the design on computer, simulate again, and say, hey, this is how it is. This is how you can prevent it from happening in future. So both hindsight and foresight can happen. So by stroke of luck, I discovered a very efficient method. It was like 500 times faster than existing methods to find where the hotspot is. When I was a student doing PhD at IIT Bangalore, it was by sheer accident. But you have to identify that you're trying to compute something else. I was trying to compute actually center of gravity, but it was finding hotspot, which I did not realize it was hotspot. My prof realized it was a hotspot, and he was walking by and saying, "What are you trying to do?" "Oh, looks like you found a hotspot." I said, "What is a hotspot?" Okay, that's how we started off.